Good morning. Greetings from Disney World. I'm here to teach you about standard form of a quadratic function and how to graph it. So go ahead and pause the video and feel free to copy down this information. This is everything you need to know about a quadratic. Go ahead, I'll wait. Wonderful. So hopefully you're done copying that all down. Now we're going to go ahead and walk through an example and I'll explain everything up here so you understand what it means. So first, a quadratic function in standard form. A quadratic function is said to be in standard form if it is of the form y equals ax squared plus bx plus c. So this function here has a quadratic coefficient of -2, a linear coefficient of 4, and a constant term of -2. So now I can start answering these questions. So concavity. A function, if the a value is greater than 0, opens up. In general, that means it looks like this. If a is less than 0, it opens down. In other words, like this. Since we see here that a is -2, we know that this function opens down. Okay. Axis of symmetry. This is a line that cuts your function in half, where the left-hand side and the right-hand side will match up with one another. The equation for that is x equals -b over 2a. So in this case, -b is going to be the opposite of 4 over 2a, which is 2 times -2. So here I end up with -4 over -4, which is 1. So the axis of symmetry, because it's a line, I expect the equation of a line. I'm going to go ahead and write here x equals 1. That's my axis of symmetry. Once I know the axis of symmetry, that line will always go through the vertex of the function. Therefore, I know the x value of the vertex. The x value is going to be 1. In order to find the y value, I'll go ahead and evaluate this function at x equals 1. So this becomes -2 times 1 squared plus 4 times 1 minus 2. 1 squared is 1 times -2 is -2. 4 times 1 is 4 minus 2 is 0. So I end up with the point 1, 0. Okay? My y-intercept. We know that the definition of a y-intercept is the value of y when x equals 0. So if I evaluate this function when x equals 0, the ax squared term disappears, the bx term disappears, and I'm left with the value c. So in this case, I'm left with the point 0, -2. That is going to be my y-intercept. Now I can go ahead and I can describe the vertex of this point. I have a lot of information here. I know that this function, because it opens down, has a maximum value of, in this case, f of -b over 2a is 0. So it has a max of 0, which occurs at the axis of symmetry. So at x equals, in this case, 1. So that's how I can go ahead and describe the max or min of the function. Now finally, the domain and the range. Now here, the domain of this function will always be the same. It will always be all real numbers whenever we're looking at it in Algebra 2, Chapter 4. The range of this function, y will always be an element of real numbers, but now because it has a maximum value of 0, I can go ahead and say here that y can never go beyond that maximum, so it'll always be less than or equal to 0. Now I have all the information I need to be able to go and graph my function. I actually have more information than I need, but let's go ahead and graph it. The axis of symmetry is a vertical line at x equals 1. So here is my axis of symmetry. I know that the vertex is at the point 0, 1, which is right there. And I know the y-intercept is at the point 0, -2. Now because this is an axis of symmetry, I know that this point must also be reflected over here. So since it's one space to the left, I need another one that's one space to the right. And that usually gives me enough information that I can go ahead and start to graph my parabola. So I know my parabola is going to look something like that. Again, if you don't get a good y-intercept that fits on your graph easily, feel free to go ahead and just pick a point to the left or the right of the axis of symmetry and get a nice point that way. All right, good luck and happy hunting when you're working on those problems.